All right, this is Chapter 7's review. I'm on page 325 in our book. The first thing I want you guys to look at is the review key vocabulary. We learned a lot of new words, and in here it tells you where you can find those if you don't remember what they are, but I think you guys know these pretty well. For example, the first one is square root. The square root of something is like the opposite of when you are squaring it, right? So like if I said what's 5 squared, what's the answer?
25.
Now what's the square root of 25? 5. So it's kind of like they're opposites, right? A perfect square just means that it is a square root that has a nice number that comes out. Like the square root of 25 is 5, so it's considered a perfect square, okay? A radical sign. What's a radical sign?
The square root sign.
The square root sign, yep. We didn't really talk about a radicand. How about a perfect cube and a cube root? Same thing?
Yeah.
It's just that instead of a number times itself once, you're timesing it itself 3 times. Yep. Okay, then we talked about the Pythagorean theorem. The Pythagorean theorem only works for right
Triangles. Oh, yeah.
right triangles only. Do you remember what the theorem is?
Yes. A squared plus B squared equals C squared.
Good job. A and B are legs, and C is the hypotenuse. Very good. And then we talked about classifying numbers as either rational or irrational. Irrational can never be written as a fraction. Okay? Rational can be written as a fraction, and then there's all these little subcategories of rational numbers. Underneath rational is integers. Integers are whole numbers and their
Natural.
No. Integers are whole numbers and their opposites. Underneath integers, then we have
Whole numbers.
whole numbers. Whole numbers are 0, 1, 2, 3, 4, 5. Yep. And then underneath that, we have natural. That's how you naturally learn how to start counting, right? 1, 2, 3, no zeros, no fractions, no decimals, okay? Okay. Then we talked about the distance formula. The distance formula is what we use to find the distance between 2 points on a coordinate plane if you're not able to just count them. Okay?
Okay.
All right, let's start this review. 7.1, finding square roots. I'm right here in the book. I see the first example. It says, find the negative square root of 36. Now, the square root of 36 is 6. But what should my answer look like if it says it's the negative square root of 36? It should be negative as well. And now there are quite a few on the test like that. Let's say you put that the answer was just 6. You don't get it right because it asks you to find the negative square root of 36. So your answer has to be negative 6. All right, let's go ahead and do number 1 together. You guys can use a whiteboard for these when we do them together. I'll use my iPad, obviously.
So we don't need our notes?
Use your notes because I'm going to flip back to them, but use a whiteboard to do these problems.
Oh, so we're not turning it in?
No, nothing's getting turned in. All right, I'm looking at right here. It says exercises, find the square roots, number 1, 2, 3, 4, 5, 6. Let's do number 1 first. Find the square root or roots. Now, this square root is positive. It doesn't say plus or minus. It doesn't say negative, so our answer is just going to be plain old positive, right? What times itself is 1?
1.
So this one's pretty easy. What's the square root of 1? 1. Pretty easy. How about number 2? The negative square root of 9 over 25. Now, before we even start solving it, I know the answer is going to be what?
Negative.
Yes, the answer will be negative. Now, do you guys remember this is how we solve it? We take the square root of 9, and then we take the square root of 25 separately. Kind of like this, square root of 9, square root of 25. Now, what is the square root of 9?
3.
So that's your numerator.
And 5. 3 over 5.
And 5, and then we said to keep it
Negative.
negative. So our answer is negative
3/5.
3/5. Okay, number 3.
Oh. This will be probably 3.
Okay, so we know that the answer is going to be plus or minus. We have to keep that in mind first, okay? So put the plus or minus.
It's 1.3.
Now, 1.69, the square root of 1.69. Now, I don't want you to use your calculator. How could you solve this without a calculator?
You could do every number by itself.
Here's what I would do first.
Oh wait, yeah, you.
Turn it into a fraction. What is 1.69 as a fraction? Well, it's 1 whole and 69 over 100.
Yeah.
And now I need to make this into an improper fraction. What's 1 times 100?
100.
What's 100 plus 69? 169 over 100. Now, the square root of 169 over 100. The square root of 169 is 13?
Yes.
That's my new numerator then. And what's the square root of 100? 10 times 10 is 100. So the answer is plus or minus 13 tenths. You can leave it as 13 tenths. Okay? It's slowly, like as you can see, as I'm doing it on the iPad, it's slowly updating on the computer because they're connected somehow. So do you see that it's like slowly coming in?
Yeah.
So what I did is I made this into a fraction. It's 1 and 69 over 100. I times plus this to make an improper fraction. The square root of 169 is 13. The square root of 10 is 100. So your answer should look like this, plus or minus 13 over 10.
All right.
Does that make sense? All right, guys, evaluating. Remember, these ones look ugly and scary, but do they end up being kind of nice and easy?
Yeah.
Usually they are. Let's go ahead and look at number 4. 15 minus 4 square root 36. You can write that on your whiteboard. We always do square roots first. They're kind of like exponents in a way when it comes to the order of operations, right? What is the square root of 36?
6.
Okay, so underneath it I'm going to write 6.
6 times 4.
Yes, it's 6 times,
4.
is it 4?
Negative 4.
It's negative 4. 6 times negative 4 is,
Negative 24.
okay, so now put that 15 next to it. It's 15 minus 24.
That was the easiest.
Negative 9. Yep, you got it. Oh, do you see how it's like slowly updating? That's cool. So I took the square root of 36 and got 6. I times that by negative 4 and got negative 24. And then I just kind of scooched my 15 next to it because that negative sign doubled as a subtraction sign. Does that make sense?
Yeah.
Okay. Number 5. The square root of 54 over 6 plus 2/3. Now, remember, I'm looking at this right now, and I'm thinking there's nothing times itself that's going to get me 54 or 6.
4 divided by 6.
Yeah, divide it. We can divide it, right? What is 54 divided by 6?
9.
So I'm actually taking the square root of 9 plus 2/3.
3 plus 2.
Good. The square root of 9 is 3. 3 plus 2/3. You don't even have to do math. That's just 3 and 2/3. Right?
Oh yeah.
3 wholes plus 2/3. That's just 3 and 2/3. Any questions on 5?
No.
Feel okay on that one?
Yeah. I feel like this is the easiest thing we've done.
It's very easy. I think one of the big things we have to remember, though, is when it says the square root of 54 over 6, a lot of kids are going to say, I don't know the square root of 54 or the square root of 6. Don't do that. Just divide them and get 9, and then the square root of 9 is something nice, okay? Does that make sense?
Yeah.
All right, number 6. According to the order of operations, what do I have to do first?
The things in the
Inside the parentheses first, and inside the parentheses I have to do the square root. What is the square root of 81?
9.
So now I've got 10 times 9 minus 12, and those are in parentheses. I have to do 9 minus 12 first.
It's 9.
What does 9 take away 12?
Subtract first.
Are you?
Signs are different, so we subtract.
Yep. So it's negative 3.
Negative 3. Now I've got 10 times negative 3.
Positive, isn't it? Because 10's bigger.
Nope, that rule is for when you are taking the sign of the bigger number after you've subtracted. In multiplication and division, 2 negatives make a...
Positive.
This is just one negative,
Yeah.
so I'm still negative, right?
Didn't you say an odd number
It's
and
30.
negative?
Odd number of negatives make you still negative in
Wow.
multiplication and division. Hey, do you see how it filled in?
48 off.
So I've got the square root of 81 is 9. 9 minus 12 is negative 3. 10 times negative 3 is negative 30.
And that's why parentheses are important, because I did not put my parentheses in, and I did 10 times 9.
Yes,
Yeah.
I'm glad that you realize that. The parentheses are so wildly important. And in a calculator, if you didn't have parentheses in this, they wouldn't do it correctly either, right? A calculator would do not the order of operations. So, that was section 7.1.
I want to just type it in.
Any questions on 7.1? It was just square roots.
John, it really doesn't.
Kids, square roots. Feel good?
Yeah.
No questions?
No.
Okay, I'm going to go ahead and erase my page, and then we are going to move on to section 7.2, cube roots. Cube roots are kind of like square roots, except for now you have to find what times itself 3 times gets that number, right?
Yeah.
So for example, the first one says find the cube root of 125 over 216.
I wish it was as easy as just dividing it by 3.
All you need to do is find the cube root of 125 and then the cube root of 216. So you would take it separately, right? The cube root, so 5 times 5 times 5 is 125.
Yeah.
Okay, so the top number will be 5. What times what times what gets you 216?
Hold on.
The phone is ringing. 6.
A 6, yep.
That's a nice iPad. I want to get an
5,
iPad.
6.
You guys are working
So
with
the
mom
cube
like
root of
that
that is
for the test. 6.
Yeah, and then they have like all
But
those for
smaller.
the iPads.
It has like
the
a.
iPads that you can use for this thing. Like they all.
Wait, is it hard? Did you do this kind of math? No, you didn't even do
John,
this.
they went to the office.
Oh, John, what'd you do?
What'd you do, bro?
All right.
Probably for the test.
So what is the cube root of 125 over 216?
5, 6.
5, 6. That's it.
Yummy.
Remember, you just take them and you cube them separately like this, and it still is a fraction at the end, okay? Yes?
Yeah.
Yes.
Okay, let's do the exercises. Number 7. Find the cube root of 729.
9.
9 times 9 times 9?
Yes.
Yes, ma'am.
9 times 9 times 9. So the cube root equals 9.
Nice handwriting, really.
Okay, how about number 8? What is the cube root of 64 and 343? So remember, do these ones separately like this, and then keep them as a fraction. The cube root of 64,
4.
4 times 4 is 16. 16 times 4, 64.
Yes. 7 is the 343.
Okay, so we've got 4 as our numerator. And then you said, what was cube root of 343?
7.
7. So my answer is
4 7.
4 sevenths.
I'm ready to go to FF.
You will be able to use a calculator on this test for the cube roots and things like that. Okay?
On the
The chapter
math
test?
Oh,
Yep.
that is the math test.
On this math test, you will be able to use your calculator to get
You
these
should
things.
just do, like,
Could you figure this out though on your own?
Yeah.
Yeah.
You really could, because if I didn't know the cube root of 343, I can just start with 5. I always like to start with 5. What's 5 times 5?
25.
25 times 5.
125.
125.
Wait.
I don't think so. I think it's 225.
5 times 25?
Yeah.
Times 5 times
25 times 5.
It's 125.
It's 125.
Oh, okay, so then from 5, I know I got to go higher then, right?
Yes.
Because that's not 343.
Thursday there was a pop explosion. It wasn't.
Okay, let's go and go to number 9. 8 over 27. Cube root these separately.
2.
So 2 times 2
2
times
and
2 is 8.
Negative 2/3.
3 times 3 times 3 is 27.
Yes.
Now, there is a negative sign inside of this.
Negative
2/3.
Negative 2/3, yep.
It's like
I love
8
that they
divided
suspected
by
John
2
as a pop
is 4,
explosion.
and then we divide that by 2 is
Yes. And that's those factor trees that we made. Do you remember those?
Yeah.
The factor trees can help you. So if you didn't know, 27, a factor tree for 27, what times what is 27? 9 and 3? And then can I break my 3 down or my 9 down into 3 and 3?
Yeah.
So I know 3, 3, 3, that equals 27. Okay, let's go ahead and move on. Let's go down to evaluating the expressions. This is just like what we did with the cube roots, except for, the square roots. Now it's a cube root. Number 10. Go and write it on your whiteboard.
Oh, bro. I'm a little slow. Negative 13.
So the first thing I do is I worry about that cube root of 27, right? What times what is 27?
3.
We just did that one, right? 3.
Yeah.
So now it's 3 minus 16.
Negative 13.
Negative 13. That's my answer.
I love Wreck-It Ralph.
Try to stay focused. I am recording this. Number 11. The cube root of negative 64. We just did that one too.
It's 4.
Yes, but now it's going to be negative 4. Now, I rewrite it. Don't get lazy. Let's rewrite it. I got 25 plus 2 times negative 4.
So negative 8.
Good. Those two things make negative 8. And so I've got 25 plus negative 8. Signs are different, so we
17.
subtract. Is it negative?
No, it's positive. I'm gonna let
25 is
you-
bigger.
There we go.
So it's 25?
I know how to subtract now.
So it'll be positive.
So I've got 25 plus negative 8.
I can subtract.
Signs are different, so we subtracted. 25 minus 8 gets you 17. It's slowly coming in on the computer. Almost there. I don't know why it's not updating all the way. There it is. Boop. All right, let's go look at number 12. What do I do first?
That was a yummy
You
noise.
have to do the square
Square root of 125.
yeah.
The cube root.
Cube root.
Sorry.
Now, it is a negative in there too.
That's negative 5.
So I would write 3 times negative 5 minus 27.
So 25.
Wait.
Negative
Signs
29.
are the same, so you just add.
So who do I do first? I've got 3 times negative 5 minus 27. I need to do the multiplication first.
Yeah.
What's 3 times negative 5?
Negative 15.
Negative 15 minus 27. Signs are the same, so we just
Add.
add.
42.
Positive or negative?
Negative.
Positive. No, negative.
Remember, that's only for multiplication and division. That rule, 2 negatives make a positive.
Yeah.
That's only multiplication and division. I've got negative 15 minus 27. That's like saying I'm going to dig a hole 15 feet deep, and then I'm going to keep digging 27 more feet. Won't I still be in the negatives?
Yes. She got 42.
7 and 5 is 12.
Oh.
2, 3, 4. It should be negative 42.
Oh. She got it right. We got it wrong.
7 and 5 is 12. That'd make it my 2. 1, 2, 3, 4. 142. Negative 42?
Yep.
Okay. How do you guys feel about section 2?
Oh, signs are the same.
You feel better?
Yes.
Cube roots, square roots,
Yummy.
feel good?
Yeah, I think
Okay. You just have to watch those negative signs, right, guys?
so. We get a calculator.
I will let you use calculator on a test, yep. All right, let's go to the next page. The Pythagorean theorem. Yay, this is fun stuff. Remember, in the Pythagorean theorem, we've got a squared plus b squared equals,
C squared.
and a and b are legs,
Legs.
and c is the hypotenuse. Now, let's go ahead and just jump right in and do 13.
Oh, man.
13. What is missing?
The hypotenuse.
Hypotenuse.
Joey.
So to solve this, I need to take a leg squared plus a leg squared, and it'll equal c squared. 12 squared plus 35 squared equals c squared. Have that written down on your whiteboard first, okay? 12 squared plus 35 squared equals c squared.
Oh my god, that's a big number.
Now, you can use your calculators if you want. You should know 12 squared, though. 12 squared should be memorized.
144.
Okay, so it's 144 plus
1225.
1,225.
equals c squared.
1369.
So square.
So add your like terms first. What's 144 plus 1,225?
1,369.
69.
1,369 equals c squared. How do I get c squared now by itself?
You square root it.
You square root both sides, and that gets rid of the squareds.
37.
37 equals c. And does it make sense? Like, c has to be the longest, right?
Yeah.
And if it's, yeah, if it's 37, it would be longer than both of those.
Yeah.
Okay. All right, 14. Who's missing on 14?
A leg. A leg.
A leg. Okay, so to set up my equation, I'm going to have 0.3 squared plus b squared equals 0.5 squared. And those of you who were like, wait, how did they know that b wasn't the hypotenuse? Well, the hypotenuse is always directly across from
It's where the right angle.
the right angle. Yep. The right angle is pointing towards the hypotenuse all the time.
Wow, that was a smart way to think
That's
of it.
nice.
Yeah, that way it won't trip you up and go, wait, that's the hypotenuse that's missing. It's not. Okay, now 0.3 times 0.3. Well, 3 times 3 is 9. So move your decimal over 2 places. Shouldn't you get 0.09?
Yeah.
0.09 plus b squared equals 0.5 squared, 0.5. So 5 times 5 is 25. Move your decimal over 2 places.
Equals
I got it.
0.25.
Yep. Oh, let's go.
Okay?
B equals a monkey.
Yeah.
Now,
Yeah, I did.
I've got to get...
Right.
Are you listening?
Yes.
You're talking over me a lot today. I've got to get b all by itself.
So you subtract 0.09.
Subtract 0.09.
Yeah.
Okay, so now I've got b squared equals 0.25 minus 0.09.
It's 0.16.
Now, this one's really easy if you think about it. What's the square root of 16? 4. Move the decimal 1 place because 2 of them would be at 0.16, right? b equals 0.4. And it makes sense though because it looks like b needs to be shorter than the hypotenuse just by a little bit, right?
Yeah.
Is 0.4 shorter than 0.5?
Yeah.
Yeah. Okay, how you guys doing? You feel okay
Yeah.
on hypotenuses?
Yeah.
Feeling okay on the Pythagorean theorem?
Yep.
Pythagorean theorem is fun in my opinion.
I just don't like the approximately thing.
Okay, let's talk about approximating square roots. This one was hard for some of you when it's just a lot of steps you have to remember. Let's skip, let's just do the classify part. See how it says classify square root of 19?
Yeah.
First, in this chapter, we learned about how to classify, and then we learned about approximating. Now, if you go back in your notes, we talked a lot about classifying. If things are irrational, it's because they do not make a nice fraction, right?
Yeah.
In your calculator right now, take the square root of 19. What do you get?
A very ugly number. 4.358898.
So, okay, nothing that ends and nothing that I could put as a fraction, right?
Yeah.
So because of that, I would say it is
Irrational.
irrational, okay? It doesn't fit into any other subcategories. It's just irrational. Now, what if I said classify the square root of 4?
2.
Okay, so the square root of 4 is 2. Is 2 rational?
Yes.
Can I write 2 as a fraction?
Yeah.
Yeah, 2 over 1. Can I write 2 as an integer?
Yeah.
It is an integer. Is it a whole number?
Yeah.
Is it a natural number?
Yep.
Oh my goodness, 2 fits in every single rational category. So in the test or, on your homework or whatever, you'd always put down all the categories it fits in, okay? Let's go ahead and skip the whole estimating thing for a hot second, and let's just go classify. Classify, I'm on the next page. Classify number 15. So remember, there is another rule here. If it's a repeating decimal, can I write it as a fraction?
Yeah.
Yes, we learned about that, right? We had a whole section about that. So if it's repeating, does that mean it's irrational or rational?
Rational.
It's rational. If it repeats, it's rational. So number 15 is a rational number. Is it anything else?
No.
Why not?
Because it's not a whole number. It's not a
Yeah.
natural number.
Yeah, whole numbers are whole numbers, right? Whole big numbers. And a fraction is not part of that. Fractions and decimals are not whole numbers, obviously, right? If I eat half of a cookie, I don't have a whole cookie. I have a fraction of a cookie, right? So if I said classify this number, what was the only thing you would put down?
Irrational.
Rational. Okay, number 16. The square root of 101. Well, go ahead, square 101.
Irrational.
What'd you get?
10.0498.
Yeah.
Square
You get a decimal that goes on forever without repeating,
Yeah.
which means this is just
Irrational.
irrational. IRR. This says ear, and then this part will say rational. I've had irrational be spelt some crazy ways the past few weeks.
Probably by me.
Irrational, not ear as in like the ear that you hear with. A lot of people are spelling it EAR, irrational, but it's
I spell
ear.
with one R
Okay, how about the square root of 4? We just did that one. The square root of 4 is 2. 2 is rational. It is an integer. It is a whole number. It is
A natural number.
natural. Yep, everything. All right, now can we go estimate some things?
Yeah.
Okay, this part is where you guys struggled the most on the quiz, but it's not that hard. It wants you to estimate to the nearest whole number, which is an integer, and it also wants you to estimate to the nearest tenth. So it's going to be worth 2 points each, okay? Let's go ahead and look at 18 first. 18, the square root of 14. Remember, no calculators. We're estimating here.
Oh, right.
So the square root of 14. The first thing I want you to do is think of what is the perfect square above and below 14.
Oh, there's
16.
4 times 4.
Okay, so
Yeah.
what I would do on your whiteboard is write the square root of 14. Below it, to the right and to the left, that's where you're going to write the nearest perfect squares. So the nearest perfect square above it would be the perfect square of 16.
Yeah.
And then what's the nearest perfect square below it?
10. Not 10. 9.
12. That's 12's not a perfect square.
9.
9? I would think so. Okay, so on your whiteboard, I would have the square root of 9 over here, the square root of 16 over here.
It's 16.
So now, right now, we're trying to find out if it's which one it's closer to based on a whole number. It's closer to 16. Now, the square root of 16 is what?
4 times
4. So I would say the square root of 14 is approximately
4.
4. That's part of your answer. Like, that's the first part. A wants the whole number, the integer that it's most closest to, and that would be the square root of 4. Or sorry, square root of 16. Now we got to find the nearest tenth. So here's what I do next. I draw kind of like a little number line, and I put 4 in the middle. Who goes to the left of it?
9.
Well, think of like an actual number line. Who's to the left of 4?
3.
Who's to the right of 4?
5.
So I've got a number line that has a 3, a 4, and a 5, okay? I know the square root of 16 is 4, right? So that means I need to go lower. I need the square root of 14.
Oh.
I know the square root of 9 is
3.
3. So above 3, I write square root of 9, because I know the square root of 9 is 3. Above 4, I write square root of 16, because I know it's 16 to make 4. It's a little leggy. It's coming in soon. That means the square root of 14 has to be between 3 and 4. Somewhere, right?
So 3.2 or something.
Yeah, 3.2.
We can go ahead and kind of figure that out, but we just tell me, though? Here's the thing. You just told me that the square root of 14 is about 4, right?
Oh, so
3.2 would round down to 3, not 4.
It's
So it's got to be 3.5 or higher, right?
0.8 makes it 14.44.
Okay, so we try 3.8?
Yeah.
Let's see what 3.8 squared is. What is 3.8 times 3.8?
14.44.
14.44.
3.7 is 13 by 69.
Yep.
yeah.
3.7 is what?
13.69.
Okay, so which one is closer to 14?
13.69.
Yeah, 13.69 is closer to 14 than 14.4. Oh, wait, what was it? 14.44? Yeah, it is. So I would say the final answer here is the square root of 14 is approximately 4, and it's also approximately 3.7. The reason why I make this number line right here is so that I can really start thinking like, okay, the square root of 9 is 3, the square root of 16 is 4. I know the square root of 14 has got to be one of these digits in between here, right? It has to round up to 4 because I just told myself it was about 4. That means it's gotta be 3.5 and above, right?
Do we have one of those examples in our notes?
Yes, we do. The example in our notes is on the, let me look for it. It's on 7.4, and it's at the very bottom of that bar. We found approximate. All right, let's go ahead and do 19. I want you to approximate the square root of 90, the nearest integer, and the nearest tenth. So once again, the first thing you're going to do is you're going to write the nearest perfect square above and below 90.
81 and 100.
Ooh, good job. 81 and 100.
Yep.
The square root of 100 is 10. The square root of 81 is 9. So that means it's approximately closest to,
81.
it's only 9 away from 81, whereas it's 10 away from 100. So it's actually closer to,
81.
what is the square root of 81?
9.
So I would say the square root of 90 is approximately 9. Now you can literally just make your number line from here. Do you see my numbers that I wrote? I got a 9 and a 10. I need a number line between 9 and 10 because I know it's going to be somewhere in between there, right?
Yeah.
What digits are between 9 and 10? There's 9.1, 9.2, 9.3, 9.4. So I know it's got to round down to 9, not round up to 10. So that means it's either going to be 9.5, 9.4, 9.3, 9.2, 9.1.
9.4 is 88.36.
Hold on, tell me that again. 9.4 squared,
88.36.
88.36.
If you go up, it goes up.
9.6.
We want 90.
It goes up more.
Yeah, it goes up.
It goes up too much.
Yeah, 90.
So what is 9.5 squared?
90.25.
90.25?
Yeah.
Remember, it's not a bad thing if it goes over, it's whoever's closest. So for example, you told me that 9.4 squared was 88.36.
Yeah.
Is that closer to 90 or is 90.25 closer to 90?
90.25 just by a little bit.
Okay, so that means which one do I want to pick? Do I want to pick 9.4 or 9.5?
9.5.
9.5. So I would say it's approximately also 9.5. Now, if I wanted to go even closer, then I know that my digit would be probably one less than 5. It'll probably be 9.54 or 9.53, right? You can even put the square root of 90 in and see if I'm close. What is the square root of 90? It should be 9.54 or 9.53.
9.48.
9.48. Okay, so then 8 would round that 4 up to a
5.
5. Yeah, so it makes sense that we got approximately 9.5 though, right?
Yeah.
Yeah. There are, I think, 3 questions like this on the test. Let's do one more to make sure you guys feel real confident in this, okay? I want to find the approximate square root of 175. So remember, you put the next perfect squares above and below. What was the 169? Wasn't that 13 squared?
I think so.
Yeah.
Yeah.
Okay, so I'm going to say the one below is going to be 169, and I know that's 13 squared. So now, what's 14 squared? Because that would be the next number besides 13.
196.
So I think that would be the next perfect square.
Yeah.
And that was 14. Is 175 closer to 169 or 196?
165.
Okay, so I'd say the square root of 175 is approximately 13. Now, make your little number line. Something, square root of 75's got to land between 13 and 14. And I did just say that it's going to round down to 13, right? So I know that it's going to be 13.1, 13.2, 13.3, 13.4. It's got to be something in there, right? It could be 13.5 as well.
13.2.
What is 13.2 squared?
174.24.
174.24?
Yeah.
And then what's 13.3 squared?
176.8.
Ooh, that's way farther away from 175 than what we just got, right?
Yeah.
So I'd say it's approximately 13.2. How do you guys feel about approximating?
Good.
Honestly,
Yeah.
are we feeling okay?
I feel like since I did it again, it feels better.
Okay. There are a couple questions on the test, and I am recording this. So, guys, if you want to watch this tomorrow, I'll put it on the Google Classroom. You can watch it tonight.
I can help on the test. So I'll be in here.
Where are you, oh yeah, you'll be gone.
Oh wait, that means I'll be gone too.
Well, no.
You guys
I'm
both
recording this for the kids who are going to be gone today.
You leave
Are
Thursday.
you listening? Are you listening? I'm recording this for the kids who are going to be gone today for the review. But since I'm recording it for them, can't you guys watch it as well?
Yeah.
And couldn't this help you for the test tomorrow?
Yep.
Definitely. Please do.
Edit your video.
All right, let's go on. Let's go to 7.5. 7.5 was using the Pythagorean theorem. So they kind of jumped around on us a little bit, but it's pretty easy. All you did in 7.5 when using the Pythagorean theorem is they asked questions like, is this a right triangle? So if they gave you 3 random side lengths of a triangle and they said, is that a right triangle? Could you figure it out?
Yeah.
Yeah. For example, if I said right here, that guy, do you see that tent? I've got 80, 48, and 64, and it says, is this a right triangle? How do you prove if something's a right triangle?
It has one longer than the rest. No, you do the thing.
Pythagorean theorem?
Yeah.
If this is a right triangle, then that means a squared plus b squared should equal c squared, right?
Yeah.
So to prove it, you would say 64 squared plus 48 squared should equal 80 squared. In your calculator, you can take 64 squared and 48 squared. What do you get when you take 64 squared?
4,096.
Yeah, for
4,096.
yeah.
And then 48 squared.
2,304.
Okay, and then do 80 squared.
6,400.
6,400. Now, does 4,096 plus 2,304,
Yeah.
does that equal 6,400?
Yes.
Yes, it does. So if it equals 6,400 and 6,400 equals 6,400, doesn't that mean that is a right angle?
Yeah.
Yes. So in this section, we did things like that to prove if things were 90 degrees. Pretty easy.
Yeah.
Then they jumped at you and they said, hey, guess what? We have a really cool formula that helps you find the distance between 2 points. It's called the distance formula. The distance formula is the square root of the change in x's plus
The change in Y.
change in y's, but both of those things are squared. Yep. So let's go do an example for that. I'm looking now at the bottom. It says exercises 24 and 25. Should we do those ones first? And then do the distance formula?
Yeah.
Okay, let's do 24 first. Is this a right triangle?
Yeah.
How do I figure out if it's a right triangle?
Well, if you do the
We have to do the Pythagorean.
60 squared plus 11 squared, should that equal 61 squared?
Yeah.
Okay. 60 squared is
3,600.
3,600. 11 squared is 121. And 61 squared is 3,721. Is 3,600 plus 121, is that 3,721?
Yes. No. Yes.
Yes. So is this a right angle?
Yes.
Yes, it is.
Why, yes.
Why, yes. Yes, it is. All right, let's skip 25 for now. Let's go down to finding the distance, okay?
Okay.
All right, are we ready for number 26?
Yeah.
Okay, stay with me. I know it's hard because you can't see what I'm doing on my screen up here. I'm trying to do it verbally with you, so that's tough. First thing I want you to do is draw me a real nice long square root. A nice big long square root. The distance formula is the square root of the change in x's squared plus the change in y's squared. That's it. The distance formula is the change in x's squared plus the change in y squared. First of all, who are my x's?
Negative 2
5 and
and
5.
3.
My x's. Negative 2 and 3. Those are x's, right?
Oh,
Yeah.
yeah, okay.
So now I want the change in x's. The change in x's means subtract them, right? Negative 2 minus 3. And then after I do that, I'm going to square it.
Yep.
So on your whiteboard right now, you should have a big, long radical sign. And then underneath it, all I've got so far is negative 2 minus 3 in parentheses, and then outside the parentheses, they are being squared. I haven't done the math yet. It's kind of slowly coming up on my screen now. Do you see it? Negative 2 minus 3 squared plus, now find the change in y's. If I went this direction last time, I've got to go this direction the next time. It's negative 5 minus 5
Yeah.
squared. Okay. What is negative 2 minus 3?
Negative 25. Wait, what? 5.
Negative 2 minus 3 is negative 5?
Yes.
What's negative 5? It's in parentheses, so that means it's going to be negative 5 times negative 5, right? For squaring it?
Negative 25.
Is it negative?
Positive 25. Positive.
Positive, good. Now over here I've got negative 5 minus 5, that's negative 10 squared. Would be 100. What's 100 plus 25?
Negative 25.
Don't forget, we got that big square root. It's actually the square root of 125 at the end, right?
No.
And the square root of 125 is?
Negative 5.
Is it negative?
Oh, wait, no, it's positive.
Distance.
Like that.
Remember, we're finding distance, guys. Should distance ever be negative?
No.
No. What's the square root of 125?
You can't do that. 11.18033. No.
The square root of 125?
Yeah, it's 11 point
Oh.
something.
It's
11.18033.
Okay.
Can't do that.
So then what did we learn? If it's something that's not pretty, what do we do?
Like that. Keep it.
We just keep it just like that.
Just do
The distance is, distance equals square root of 125.
That was.
But like technically then, what that means then is on the coordinate plane, those 2 points are about 11 points away.
Yeah.
11 spaces, 11 units away. Okay? Okay. Let's do the next one. Number 27. The first thing I need to do is make one giant radical sign. Right?
Yeah.
Okay. Change in x's squared plus change in y's squared. Who are my x's?
Negative 4 and 4.
So it's going to be negative 4 minus 4 squared plus change in y's
7 minus 7.
squared. Negative 4 minus 4.
8.
Negative 8.
8 squared.
Negative 8 squared is just
64.
64. 7 minus 0. 7 squared. Good. So now it's just the square root of 64 plus 49. What is 64 plus 49? 113. So it's the square root of 113. It's nothing cute. It's 10 point something, right?
Yep.
So my answer can just be the distance is the square root of
Square rooted.
113.
Square rooted.
Would it matter if, so like you did negative 4 minus 4? Would it be fine
If you went the other way?
Yeah, you.
Definitely. So Zoe's question is, if I said negative 4 minus 4, could I also say that this is 4 minus negative 4? Yes, but then when it comes to my y's, I need to make sure I go that direction as well. So instead of saying 7 minus 0, I would have said 0 minus 7. Does that make sense?
Yeah.
You can go either way as long as you go either way for both the x's and the y's. I just like to read left to right. But sometimes, though, I like to do what Zoe was thinking. It's really fun making double negatives. So I probably would have said 4 minus negative 4 and just said that's 8. But at the same time, it really doesn't matter, right?
Yeah.
Okay, now there was one thing I noticed they did not give us on this little review. And it was our extension we did yesterday.
Oh, yeah.
What was our extension we did yesterday? Do you remember?
Yeah.
Turning a repeating decimal into a fraction. So I'm now looking at page 328. It's the chapter test, like the practice chapter test in the book. Look at number 16 and 17. 16 and 17. It says write this decimal as a fraction or a mixed number. Now let's do a quick little review. Step 1, set it equal to
10.
x. X equals negative 0.3 with a hat.
Yeah.
Now multiply each side by
How many numbers it has past them?
So it's got one digit that repeats. That means it's going to be multiplied by 10. So now I have 10x equals
3.3.
negative 3.3 with the hat. Because remember, it moves it over one place. Now subtract your original equation. (9x) equals
Negative 3. Let me see.
just be negative 3.
Yeah.
Because the 0.33333, 0.33333, they go away. So now I'm just left with negative 3. Okay, don't forget to study that section because it will be on the test as well.